Hi guys, welcome to this video on this beautiful British sunny day for a change, where we're going to be looking at a problem from a book that I've used in a few of my videos before. We're going to be looking at a problem from this book, Challenging Problems in Algebra by Alfred Posamentier and Charles Salkind, and the problem is from chapter 8. This is one of my favourite books for problems. So chapter 8, problem number 4. So there's four parts to this problem. There's the initial part, and then there's 3 challenge parts. So I'm just going to go through the initial part and the first challenge part, and I'm going to leave the other challenge problems because I think you'll kind of get the idea about what kind of things you need to do in order to solve the problems. So the initial part of this, by the way, this is a brand new YouTube channel, or fairly new YouTube channel. I'd really appreciate it if you'd give this video a thumbs up, and if you'd subscribe to this channel if you haven't done so already. I'd be really grateful for that. Cheers. So find the smallest value of x, satisfying the conditions x cubed plus 2x squared equals a. So x cubed plus 2x squared equals a, where x is an odd integer and a is the square of an integer. In other words, a is a square number. Okay, so that's the information that we're given. So let's have a look at how we might attempt this problem. So I spent a few minutes thinking about this, possible ways to go about this. I was thinking about bringing the a over here, maybe, and writing x cubed plus 2x squared minus a equals 0, and trying to find some sort of a factorization for that, but I didn't really seem to make any progress in that direction. So I thought, I didn't think that this was going to work, but fortunately it did. So what I did was I factorized the left-hand side of this to x squared times x plus 2 to give x squared times x plus 2 is equal to a. Remember, a is a square number. Okay, so we know that x is an odd integer. So x is odd, so that means that x squared is going to be odd. So it's not difficult to prove that the square of an odd number is again odd. Let's go through it here. So 2n plus 1 squared is going to be equal to 4n squared plus 4n plus 1, which is twice 2n squared plus 2n plus 1, which is 2k plus 1, which is the form of an odd number. So if 2n plus 1 represents a general odd number where n is equal to, let's say, 0, 1, 2, 3, whatever, then the square of this number is also a square number. So x squared is going to be odd, and also x plus 2 must be odd. If I start with an odd number, 3, add 2 to it, I get 5, another odd number. Add 2 to it, I get 7, another odd number. If I start with 57, add 2 to it, I get 59, an odd number. And therefore, the product, this is going to be odd. It's going to be an odd number. So that means that a is odd. So it's an odd square. So that means that, actually I don't think I need to know this, but the square root of a is also going to be an odd number. I don't think that's actually relevant, but just so that we know a is an odd square number, that's probably going to be useful to us. Okay, so at this point I got a little bit stuck and I had to think again for a couple of minutes, but then I thought about, okay, if a isn't a square number and x squared is obviously a square number, and x plus 2 is an integer, so these are all integers, then x plus 2 is equal to a over x squared. In other words, x squared is a square number which exactly divides the square number a. Okay. And then I thought, right, so if a is a square number, it has an even number of factors. How do we know that? Well, okay, so if, let's say we've got the number c, and c is equal to, and its prime decomposition, or its prime factorization is, let's say, c1 times c2 times c3 times da 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 up to cm. Then c squared is going to be equal to c1 squared times c2 squared times c3 squared up to cm squared. In other words, however many factors c had, and some of these might be repeated, by the way, c squared will have double the number of factors. So if it's got double the number of factors, there must be an even number of factors. Again, some of these might be repeated. So, okay, what that means is that a can be written as a product of powers of prime numbers, even powers of prime numbers. So a is equal to, let's say, a1 to the power of n1 times a2 to the power of n2 times what shall I use, p to the power of np, where ni are even integers. X can be written as x1 to the power of m1, x2 to the power of m2 times xq to the power of mq, where mi, again, are even integers. What we find then is that if a is exactly divisible by x squared, we're going to get a number, let's say, b. Okay, where b is equal to b1 to the power of nm, let's use r1, b2 to the power of r2 times b q t to the power of rt. Okay, so the powers here of the, so b1, b2 to bt are the prime factors of b. r1, r2 to rt are the powers of those prime factors. They must also be even. So the ri are, again, even integers. So that means that b must be a square number. So b is a square number. Not only that, it must be an odd square number. So what we're looking for then is a value of x must be 2 less than an odd square number. Okay, so what are the possible square numbers in that case? Let's get rid of this. By the way, on this YouTube channel, my focus is on problem-solving skills. I do private maths tuition. I'm a private maths tutor for primarily GCSE and A-level maths here in the UK, and particularly in Leeds, but I do online tuition. If you would like some help with your maths, GCSE and A-level maths, please feel free to get in touch, and maybe we can come to some arrangement. I'd love to be able to help you with your problem-solving skills and help you get the grades that you want to get into college, sixth form or university, whatever course it is that you're looking to do. So the possible odd square numbers that we're looking at, well, the odd square numbers are 1, 9, 25, 49, 81, and so on. Okay, so it can't be 1. because we're looking for, okay, when it says in the problem x is an odd integer, I interpret this as meaning a positive integer. Okay, if x plus 2 is equal to 9, that would mean that x equals 7. Okay? And if x, sorry, I had to think for a second there. I got a little bit lost with my train of thought. So if x is equal to 7, let's have a look. What do we get? 49. X squared times x plus 2 would be equal to 49 times 9. 49 times 9 is 490. Take away 49, that's 441. 441 is a square number. It's 21 squared. So it looks like that's the solution to our problem. Let me just double check what the problem said. What was it? Chapter 8, question 4. Find the smallest value of x satisfying these conditions. So if x equals 7, then we get that x squared times x plus 2, or in other words, x cubed plus 2x squared is equal to 441, which is a square number. So that means that x equals 7 is the smallest value of x that satisfies this condition, and in that case we've got that a is equal to sorry, not 21, it's 21 squared, or 441. So x equals 7 is the solution to our problem in this case. Okay, so let's have a look at the next part of this problem. So chapter 8, problem 4. So it's more or less, it's a very similar problem to what we had in the initial part. It just says change the phrase odd integer to even integer greater than 2 and solve the problem. So in other words, the new problem that we've got to solve is the following. Find the smallest value of x satisfying the condition x cubed plus 2x squared equals a, where where x is an even integer greater than 2, even integer greater than 2, and a is the square of an integer, so it's a square number. Okay, so maybe kind of naively, in many respects, I attempted to solve this problem using a very similar approach to what I used for the initial part, for the part that we've just had a look at. I didn't necessarily expect this to work, because sometimes what can happen is, even with very similar problems, very similar wordings, but slightly different information, they can require completely different methods of solution. So just because you've solved this problem in this way, and then you're given another problem that very closely resembles the first problem that you've just solved, but there's a little change in the information that you've been given, don't bank on the fact that this solution that you found for the first problem is going to work over here as well. It might do, it might not do. Sometimes it does, sometimes it doesn't, but don't count on the fact that it's going to work, or it's forced to work. Sometimes you might have to look for a completely different method of solution. It just happens in this case that a similar method of solution works in both cases. But it is in the nature of problem solving to for things just not to work quite as nicely or straightforwardly as that. So just be prepared for that. So as in the first part, I factorized the left hand side, so I got x squared, x plus 2 equals a. So we know that x is an even integer greater than 2. So x squared is also going to be an even integer. This is not difficult to prove. For example, if 2n is my even integer, so n is 1, 2, 3, 4 or whatever, let's square this, I get 4n squared, which is going to be twice 2n squared, which is 2k. So in other words, when I square an even integer, I get a correspondingly even integer. X plus 2 must be even as well. And therefore a is going to be even. But we also know that a is a square number, so it's an even square. Okay, so I use a similar technique, noticing that x plus 2 equals a over x squared. There's no problems with me dividing through by x squared. X can't be equal to 0 or anything like that. So because x plus 2 is an even integer, or the fact that it's just an integer, means that a is exactly divisible by x squared. Okay, so a similar situation to what we had before. I can think of a as being equal to a1 to the power of n1 times a2 to the power of n2, ap to the power of np. And what I get is that if this is equal to b, b is going to be a square number. So I'm not going to go through all the details. It's exactly the same as what I did in the previous part. So b is a square number. And if b is equal to x plus 2 is an even integer, then b must also be an even integer. Which also means that because b is a square number, an even square number, x plus 2 must be an even square number. And so x must be 2 less than an even square. Okay, so what are the possible even squares? Well, x is an even integer greater than 2. So x can't be equal to 2. X plus 2 can't be equal to 4. Because that would mean that x is equal to 2, but we know that x is an even integer greater than 2, so it can't be that. So what's the next even square? 16. And in that case, we'd have x equals 14. So let's try that out. And this is the only way, really, to just try things out at this stage. Admittedly, it could be a large square number that you're looking for in here, but for the time being, I'm just going to start by actually trying things out one at a time. If it did get to a point, and it's not going to in this case, but if it did get to a point where I was just trying things out and nothing seemed to be working, then I might have to go for might have to try to find a more subtle approach. But that's not the case here. Trying things out one at a time systematically is a valid way of solving a problem. It is a bit of a risk because it doesn't always work, but sometimes it can pay off. And in this case, it did pay off. So let's have a look. So if x is equal to 14, then x squared, 14 squared, times 16. So this is x squared times x plus 2, by the way. Okay, so I don't really fancy getting my calculator out. So what I know is that this is going to be 7 squared times 2 squared times 2 to the power of 4, which is 7 squared times 2 to the power of 6, which is 7 times 2 cubed, 7 times 8 squared. In other words, 56 squared. X squared times x plus 2, when x is equal to 14, is a square number. It's the square of 56. So the value of x that I'm looking for is 14. the value of a that I'm looking for is whatever 56 squared is. But this is the smallest value of x which satisfies this information. And that's the solution to our problem.